Okay, hi. So we are in Chapter 7. So Chapter 7 has this nice little purple packet with it that kind of takes you through all the examples that we're going to do. Again, Chapter 7 only covers Sections 7.1 and 7.2, but the amount of information in there is like 5 sections worth of information. So we will just kind of chip away at it. Today we're going to start in 7.1, just finding area. Okay, we kind of already talked about this previously and just kind of talked about the basic idea of the ceiling minus the floor concept. So I'm going to be using that a lot as we go through these notes. And really this is the area between two curves. Okay, so it's not just any old area, it's this specific kind of area. And everything that we do in this chapter is going to need a sketch, whether it says it or not. So I need to see your sketches. Okay, so we're going to start with a nice simple example, right? It says find the area between y equals 2 minus x squared and y equals x. So I'm going to start off with a sketch of that. It's super awesome if you try to label your axes and all that, but again, it's just a sketch, so it doesn't have to be perfect, but as accurate as you can be will sometimes help you out. So I'm going to start with this function as my blue function. I'll kind of think of this as my f function, even though it's called y, and graph 2 minus x squared. So that's a parabola that's going to come like this. Remember that it's zeros here and here are plus and minus the square root of 2. And then, of course, we have y equals x, which I'm going to kind of think of as my g function. And then I'm going to plot just that nice simple line like so. Okay, so that's going to come through like this. Right, and so what I have, right, is this space between them, and it helps to shade that region in so we all know we're talking about the same space, right? That space goes down below the x-axis and it's cut off, right? So you can see here that the blue or f function is the obvious ceiling and that the pink function is the obvious floor, and they do not change at any point. The blue is always the ceiling and the pink is always the floor. So to figure out this area, we're going to go ahead and write an integral, right? We're going to take the f function, which is the ceiling, and we're going to minus the floor, which is that. Okay. Now, this isn't going to be worth a number for the area between these two curves until we have what? Think about that in your head, right? We're going to need to establish some limits. So we're going to need to come up with these limits, and it's very simply, right, the intersection of the two functions. Okay. So when we're doing these examples to start off with today, it's going to always be the x value of their intersection, right? Let me zoom in a little bit so you can see that. Oh, hello, sun. What an awkward glare you have. So we have to go ahead and find that intersection in some cases, and some cases it's given to us. And then we have this guy, of course, is the right intersection point, so that's going to be our b value here. So this is a, and then this guy over here is b. So let's go ahead and figure out where they intersect, right? This is a simple enough functions that you can just set them equal to one another. So I'm going to go ahead and do that. Equal to x. Since it's quadratic, right, I'm going to go ahead and get it equal to 0. So x squared plus x minus 2. Turns out that I can factor this, right? So I have 0 equal to, of course, x plus 2 and x minus 1. And if I use zero product property, I get negative 2 and positive 1. And those answers, right, this is not a coincidence, should align, right, with negative 2 being this intersection point over here and positive 1 being that intersection point over there. So negative 2 and positive 1. So again, this is my left intersection point, and then this guy up here is my right intersection point. Okay, on the AP test, right, you may have to actually figure these out by hand or by calculator. Okay. In addition, sometimes integrals in this chapter just say set up the integral and you do not have to find the answer. Okay. So it'll depend. I want you to think too, what is the area between two curves going to be? What check can you do mentally to every answer that you get to ensure that you did it right? Okay. As in the past, right, area and volume have always been positive in your life, and they are going to continue to be that. So every answer you should get should be positive. If it's not, maybe you switched the ceiling and the floor or did something weird like that. So you can go ahead, pause the video. I want you to work out this integration, okay, and tell me what you get. Okay, so for this integral, you should have gotten 9/2. If you did not, I want you to go ahead and work it out until you do get 9/2 and try to find your mistakes, okay? These are really good multiple choice problems, so it is going to help you to simplify all the way down to a single fraction so that you can check your answer that way, okay? All right, let's look at example 2. We've got an area enclosed by y equals x squared plus 2, y equals negative x equals 0, and x equals 1. So it seems that we have a lot going on here, right? They've named 4 different functions for us, but you may find that it's really not that bad. Okay, so I'm going to go ahead and graph x squared plus 2. Just kind of try to do this pretty quickly. So I'll think of that as my f function for no good reason. And then y equals negative x. I will graph that this way. So that's, I guess, my g function. And then I can go ahead and graph. I have 2 vertical lines, right? X equals 0 and x equals 1. So those are really just going to kind of serve as boundaries for us and actual limits for our integral. Right, so when I go ahead and graph x equals 0, that's here, and x equals 1 somewhere over here, right? So you can kind of see here, this region in here, this sketch, that's what we're after, okay? So you can see the blue function is completely the ceiling, the pink function is completely the floor. So let's go ahead and set up our integral. We actually like it when we get vertical lines like this because that tells me right away I'm going to integrate from 0 to 1. My ceiling is going to be x squared plus 2, and then my floor is minus negative x, right? Okay, so there's my setup. Please include the dx at the end. Crazy fact, we're going to start doing things in terms of y in the future in a couple sections here. So watch out for that. Go ahead, pause the video, see if you can get the answer. Okay, and the final answer for this one should have been 17/6. Go ahead and work that out until you get that. Okay. Example 3 is where we kind of get interesting. Okay, so this is going to be an interesting sketch for us. So we have the area between f of x equals 3x cubed minus x squared minus 10x, and then the g of x function. So something like this, right, you are not going to have to graph by hand. You have a crazy cubic like 3x cubed. So we are going to be allowed to use our calculator on some of these problems. So I'm going to go ahead and graph what that looks like now. So I've got 3x cubed minus x squared. Well, look at me always doing that. So 3x cubed minus x squared minus 10. And then I have, oh, JK, 10x. And then I've got negative x squared plus 2x. Since they're polynomials, I'm going to zoom 6 and see what I can see. Okay, so you should do that on your calculator too. There's my other function. Okay, so I do have 2 functions, and what I'm going to do when I have so many tick marks out here at the edges, I'm going to go ahead and hit window and stretch out my x min and my x max. So I think like negative 5 to 5 might be okay, so I can just kind of stretch out and see a little bit better what's going on. So there's the cubic, and then you should have the quadratic. Woohoo! Okay, and then we're going to go ahead and check for these intersection points. So we're going to transfer this sketch to our page, right, like this. But now you kind of notice, right, in this particular graph, I don't have a single ceiling and a single floor, right? They totally flip-flop. So when I sketch this, it doesn't really matter. I'm not going to do the blue and the pink thing. We're just going to go ahead and do a rough sketch, something like this, okay? But we do want to make sure to shade the region, right? Because when you put your axes and your functions on there, right, it gets kind of confusing. So I'm going to go ahead and shade all this business right here, and that's actually going to be integral number 1. So I have to do 2 integrals, okay? And then I will switch colors here and maybe do this guy, right? And here, this is going to be integral number 2. Fun, okay? So you can use your calculator sometimes to find these and sometimes to store these intersection points. So you might be able to set these equal to one another and solve by hand, but again, typically we don't have to do that. When we have functions like these, we can go ahead and find the intersection. So I'm going to find the intersection of the first curve, the second curve, and then I'm going to guess that this one, right, is about negative 2. So I'm going to type in my guess to make it go faster, and holy cow, it is negative 2. Okay, so I'm going to label this intersection point as negative 2. On my graph, right? This one looks like it should be 0 here in the middle, so I'm just going to verify that it is, okay? And then I'm going to go ahead and get this last intersection point. Again, it looks like 2, but you know how the AP test can be, so, try again. We're going to just double check that. So my guess is 2, and it is. Okay, good. Sometimes they can be crazy decimals, right? And if they're crazy decimals and you have 3 intersection points, you want to go ahead and store those as A, B, and C. And then you can just type in your integral and figure that out by hand, okay? Since these functions were named f and g, it is okay to name them that way in your setups. So my integral setup that's appropriate for the AP test is going to be, right, -2 to 0 for the black one, right? And then I'm going to use my ceiling as the cubic, right? But my cubic happens to be f of x. So I'm going to write f of x, and then minus my floor function here is g of x. So this is a reasonable integral to write for the area of the black space over here. Okay? But I have to add to that, right, the pink space. So I'm going to set up an integral for that. Same thing, now I'm going to go from 0 to 2, my left intersection point to my right intersection point. And of course, my ceiling for the pink portion, right, happens to be the quadratic function. So I'm going to do -x squared plus 2x minus, oh, JK, I'm not. I'm doing g of x minus f of x for this one, right? Okay, and then tack your dx on the end. You notice I have that in both cases because that helps you score points with the judges, literally and figuratively. Okay, and so once you've got a setup like this, I'm going to go ahead and use my calculator to type this in one single line, right? So on my screen, I'm going to go ahead and do, oh, you can't see all that. Since I have like f is my y1 and g is my y2, I'm going to use that notation. And I'm going to do math 9. I'm going to do an integral from -2 to 0. And I'm going to not type in the function here. I'm literally going to pull from the vars menu, right, the vars button down here next to clear. I'm going to pull y1 there, minus vars menu, go to y2, and then I'm going to tack my dx on the end here, right? So that's my first one. And I'm going to add to that integral the second integral. So math 9, and now I'm going to do 0 to 2. And now I'm going to reverse it, right, and do vars of y2, because that's now my ceiling, minus vars, choose y1, tack on a dx here, hit my enter key, and boom, you can't see it, but there we go. You should get 24 for that. So you want to go through that typing on your calculator and make sure you get familiar with like the keystrokes and how they work out, right? So it is kind of crazy to me, right, that an area between two random functions such as this cubic and quadratic happen to have a whole number, right, such as 24 as their area between them. That's just always kind of ironic to me that it turns out like that. Okay, if we go to example 4, I just want to kind of show you a special case in this one of what's going on. Okay, in number 4, it turns out I have y equals 0, so that's a horizontal line, right? That's also known as the x-axis, so there's that. I've got y equals -2x, which kind of looks like this. And then I have x equals 5, so let's say that's a vertical line somewhere over here. So it turns out I have this space here, which happens to be underneath the x-axis, right? Well, we can kind of think of the ceiling in this problem right here as the x-axis, right? So when I go ahead and go to write this integral, my left intersection point, of course, is 0. My right intersection point is 5. But then my ceiling function is really going to be 0, right? And then minus my floor function is entirely the -2x. So that is just something that comes up when you have to have the x-axis as a ceiling. And in effect, all it does is it changes the sign of what's going on, right? So this would be 2x integrated from 0 to 5 dx. What some people do, right, they get so excited about these setups that when it comes time to getting the answer, they forget to actually integrate. So just to make sure, right, we would do a simple power rule here. 2's cancel from 0 to 5, so I have x squared from 0 to 5. So I should get 25 for my integral, right? And that makes sense because if you think 1/2 base times height, all this is a triangle. That's the same area. Life is good. All right, so I have a crazy challenge for you in example 5. This is nuts. I want you to go ahead, sketch it, right? Shade your region. Set up your integral. It is going to be one single integral in this problem. And then find your answer by hand. This one is a little bit difficult to do by hand because there's some intricate fractions and stuff like that. So I want you to take a while, hit pause, okay, and come up with the answer. Okay, and after you did that, right, we should have turned out something like this. Here's y equals -1. We have what y equals -3x. That's even steeper. And then we have x, I guess I shouldn't want to make this. This is x equals 4, let's say. So this is obviously not drawn to scale, but this is the region here that you should have found the area of. Now it turns out that this happens to be a simple triangle. You could do 1/2 base times height, but since we're practicing the integration and stuff, your left limit should be 1/3, and your right limit should be the number 4. Your ceiling, your floor. Okay, and then did you try to integrate it? Did you get the answer? You should have gotten, I do believe, 121/6. We can verify that maybe here. I'm now making sure that I told you right, so let's see. 1/3 to 4, -1 plus 3x. Oh, good job. Okay, turns out that is the same. All right, you can see your homework is down here at the bottom. There is parts to do with no calculator. That means you need to get the final answer by hand if you can. And there is parts to do with your calculator. You can use it to graph functions, find intersections, set up integrals, find the answers to integrals, whatever you like. But when I check in your homework tomorrow, I want to see shading, I want to see sketches, I want to see integrals set up and work for the ones that are non-calculator. Okay? Okay.